Welcome. Okay, I see we are zero on live, but it's all good. I think folks will get us when we still go on, right?
Yep.
So yeah, so if you're joining us or if you're listening to this after the recording, welcome. This has been a series that has been ongoing by our friend John. John, by there, I just know what is Jane Francis? That's another name, your name, right?
Yeah. That's a French name. Actually, it's a translation
Ah,
of my name, John Muchiri, to French. So John, it's similar. Jean is John. So Jean
Eunice.
Fonse, it's Muchiri is
Conseil, eh?
Fonse Hahiko. Actually, I cut it. It should be Fonse Hahiko. So it's just my
Ah,
name translated to French.
in Francais. Okay, nice.
Mm.
So yeah. So this is John, a good friend of the channel, and actually a software engineer at a company called Cloud IT, right?
Mm-hmm.
And also now a bona fide member of a club we call PTC, Perfecting the Craft
PTC.
Community. So if you'd like to know more about PTC, I'm gonna add the link on the that's on the chat here. You can read more about it. It's a small community of folks who really care about their craft and they are trying to improve each other. So if you'd like to be part of it, you're welcome. And now I would like to take it over to John to take us through the part 3 of 4. So this is the third installment, and then we'll do the fourth installment tomorrow morning. So catch you tomorrow morning too, as we close on this review of the book, The Clean Coder. Welcome, John.
Awesome. Thank you so much, Nandaa, for that intro. And thank you for this opportunity to continue sharing this book, which is, I hope it is touching either 2 or 3 people. Our goal is to make, it's not just reading the book, but to help us to be better at our craft so that we can be more professional at what we do. And that is why we are reading this book, written by Uncle Bob. So that's another nickname of a writer. So I'm just going straight to today's section. Just a recap of what we did last time. We talked about how to say no, and we saw that you say no when the stakes are so high, especially when, or rather, if at all you say yes, something bad is going to happen. So you say no when the stakes are high, when the client, maybe you're getting a lot of cash from them, or rather you're supposed to develop a software within a certain scope. So when stakes are high, say no. When to say yes, we saw that you say yes using a language of commitment. It's not just saying yes. You say that I will do X by this time. By Tuesday, I'll be done by this. So there's a way that a software engineer can communicate and know that these people are committed. So you say yes by using a language of commitment. Then we looked at the aspect of coding, where we saw that there are many aspects that we should consider, because coding is something that you have to intertwine so many things together. And we saw that we avoid the zone so that you cannot be immersed writing some code there, but maybe you are diverting from the main goal. We also saw the aspect of being blocked. Sometimes your mind can be blocked, and we saw that can be brought by the effect of not having good sleep, and also maybe you are spending a lot of time within the maybe writing code. You should take some break, about 8 hours, write your code, and then have time to go and sleep, do some physical exercise. And so we are going to see something of the sort even today. And then we saw also about debugging time. As much as possible, write code without bugs, so that you minimize on the debugging time. So today we're going straight. The goal of this session, targeting, we cover at least 5 chapters. That is TDD, which is test development, a test driven development. So
Mhm.
you hear a lot of TDD, and then we are going to cover on practicing, and then acceptance testing, then testing strategies and time management. That is the target of this section. So I really hope that we are going to cover that so that tomorrow, and then we finish up the book with the
Mhm.
remaining bit of it. So without wasting much time, let's go into it. So,
Yes.
test-driven development. This is called TDD. You're going to hear me saying TDD so much, so just know it's test-driven development. It came in as a part of extreme programming wave, but has since been adopted by Scrum and virtually all other agile methods. Even non-agile teams practice TDD, so it came at that era. Uh, so as we continue, you can see we are improving. Last time we used slides, we are just going to find the better. We are trying to find which is better. So sometimes we use the book, but with time we are going to improve so that you can find the which is the best approach to teach the book. But this is how we are going to do it today. So TDD is much more than a simple trick to shorten my cycle time. The discipline has a whole repertoire of benefits. So what are the benefits of TDD? You're going to see them. In the early days, there were serious attempts at critique and understanding. Nowadays, however, they are just rants. The bottom line is that TDD works and everybody needs to get over it. So folks were finding it difficult. It's just like when a new thing comes in, people try to rant or rather to find something negative of it. Like we saw LLMs coming, ChatGPT. We saw people complaining. Now coders are not going to write to use they're just going to use the LLMs. But now we see we are trying to use them in the best way possible. So the same thing with TDD came in. People had issues, but now you have to get all right because it's the way to go. How can you consider yourself to be a professional if you do not know that all your code works? How can you know that all your code works if you don't test it every time you make a change? So there's no way you can know your code works if at all you don't test. How can you test it every time you make the change if you don't have automated unit tests with very high coverage? So what we are talking about, a software professional should write tests. That is the only way that you can know that your code works. So there are 3 laws of TDD, and these are the laws of how you can write this test, TDD. You are not allowed to write any production code until you have first written a failing unit test. So this is how the flow goes. You have to write the unit test first, and then now you write the code. You cannot write the code before the unit test. So number 2, you're going to find the next one is you're not allowed to write more than of a unit test than is sufficient to fail, and not compiling and not compiling is failing. So you have said you have to write the unit test first. You're not write more. So you're not supposed to continue writing the unit test, write a whole unit test of the whole software, or rather the module you're making. Now you say you're not writing the test. You have to write bit by bit. You write the unit test, then you write the code. Then you write the unit test, then you write the code. It's a cycle. So yeah, there's a flow. You're not allowed to write more production code that is sufficient to pass the current failing unit test. That is what you have said. It's a cycle. You write a unit test here, you write the code, you go that way, fixing things until they work. So, but within a few seconds, you must mention the name of some class or function that you have not written yet, thereby causing the unit test to fail or compile. So you have to write a function first. You have to write something which has not yet been written. Yeah, it's like writing the foundation. Yeah, that's the flow. So what are the benefits of unit tests? There's something here. The test fits the production code like an antibody fits an antigen. I remember my biology teacher taught me about that. That was not so good in biology. My forte was physics and math. But I remember us covering about that. So Yeah. Yeah, that is back in high school.
Mhm.
Benefits. What are the benefits? The writer is saying I simply run the unit test. If they pass, I'm nearly certain that the change I made didn't break anything. How certain is nearly certain, certain enough to ship. So the writer is saying when you write this test, then you are certain enough even to ship. So I know that is a major concern before you ship the code. Is it working? Then tests are there to cover you. So something else to get is courage when you write test. Why don't you fix bad code when you see it? Your first reaction upon seeing a messy function is this is a mess, it needs to be cleaned. The second reaction is I'm not going to touch it. The touching philosophy. There are many software professionals, or rather coders, if something is working, don't touch it. That is because your code is not well tested. Because if I try to change a certain function or variable, you have messed up the whole code. Because all the way through, you have not tested your code. So you get courage when you test your code. And by a single click of button within 90 minutes, you can know whether your changes have broken anything or it's working properly. So, let's continue. Another benefit of TDD is documentation. There will be a unit test that describe how to carry every function in the system, every way that those functions can meaningfully be called. For anything you need to know how to do, there will be a unit test that described it in detail. So it is another best way of documenting your code, because instead of just going to read the whole code, you can read the unit test and know what the code is doing. They are the best kind of low level documentation that can exist. You cannot have another better method of rather documenting or documentation. They are one of the best. So the other benefit is design. You remember we talked about you write the unit test and then you write the code. You write the unit test, then you write the code. So before you write the code, you have to write the unit test. So it means that you have to think fast about the design of the code. So that makes the code that you're writing to have a very good design, because it's well thought of. You're not writing on the fly. So therefore, following these rules will make your code to be better, and your code will be better designed. So the professional option. What is the professional option? The option of all this is that TDD is the professional option. It is a discipline that enhances certainty, courage, defects reduction, documentation, and design. With all that going for it could be considered unprofessional not to use. I think that goes without saying. Of all the benefits that you have read, then it is unprofessional not to use it. So it means many folks are out there, let me not say they are unprofessional. We are unprofessional when we don't use TDD. So what TDD is not? TDD is not a religion, it's not a magic. So I don't think that after you apply this TDD is a magic formula within your code. Following the 3 rules does not guarantee any of these benefits. Why? You can still write bad code. Even you can write bad tests. Indeed, you can write bad tests. So it's not a miracle. So, and why we are saying it's not a religion, there are times when following the 3 rules is simply impractical or inappropriate. So these situations are rare. They are very rare, but they exist. No professional developer should ever follow a discipline that does more harm than good. So if at all following TDD at that rare moment will be difficult, then it's better not to write it. But it's very rare. So that is what we are getting from the book. So yeah, on to the next, practicing. Practicing. What is practicing? So all professional practice their art by engaging in skill sharpening exercises. Musicians rehearse skills. Football players run through tires. Doctors practice searches and surgical techniques. All those guys who follow EPL. I know there are 3 elephants in the room. I don't know if they're there supporting. in a team. But yeah, so for these players to perform at their best, or rather their best performance, they have to practice. So practice takes about 95%, and then the 5% is that 90 minutes that we see them coming to play. So when performance matters, professional practice. So it doesn't go far away from the software profession. We have to practice. So we can see here a simple code. I think everyone, if at all you're coding, you cannot escape this. This is a printf hello world. I think this is written in C. Should be C or C++. Printf.
See.
This is C. Yeah. So the other languages, I think this was the first. Python is print. Yeah. And then we have system.out.print Java. Then JavaScript is on the console.log. Yeah. So you cannot. This is the first thing that you write first before you write any form of program. When you start coding, this is your first thing. And when I wrote my first print in Python, it now felt like I'm not the programmer. So the background of practicing, and I know of all the professionals, they all start from here. Even the senior engineers, they started from here. So that is the first form of practicing, like writing, executing just a program, a simple program that we all know, print console.log. So we cannot be too busy writing code to think that practicing, we were too busy writing code to think about practicing our skills. This is the writer saying that, and it's the same thing to us. Sometimes we are so busy practicing, or rather writing code, and we forget about practicing. So programmers today don't wait for compile.
So, by the quick question, John.
Yes. All right.
The writer is suggesting that you just take some time to do like practicing, other than like writing the code for production, but you're writing for practice.
Yes. Like apart from the 8 hours we talked about when you're giving the employer your time, or rather you're working on this project, then there are other hours apart from work, the 20 hours, then that is the time that you're doing the practicing. I remember we covered that.
All right.
So that is what we are talking about. You're going to see more about this practice on this chapter as we go on. So doing anything quickly requires practice. Spinning around code, test loops quickly requires you to make very quick decision. Making quick decision quickly means being able to recognize a vast number of situations and problems and simply know what to do to address them. This is more of muscle memory. We talked about practicing. I guess military takes they practice on missions. They do, or rather breaking the doors. Like they have some they practice even with some fake bullets so that they can practice the mission. So the same thing, we are talking of muscle memory. Like you're not going to look where the code, or rather you've mastered your keyboard, you've mastered how you declare the functions and the methods. So it's just something that you do until now it's part of you. Like when you compile, especially when you're working on a software and maybe you're using IntelliJ or rather VS Code, there's a way you can run the code. There's a way you just run through the command or through the terminal. You're not going to memorize that. It's something that you have done before software works. You have to run the code so many times. So you have it's just within you. So actually I've talked about compact. So the same thing with martial arts, you have to practice. So musicians practice scales and edges and riff over and over until they know them cold. Yeah? I know right now, because I know Nandaa can play the bass guitar. Anytime that you can wake up, you can wake him up in the night. He can play some scales. So you know them cold in the moment that you can do them without thinking about them. There's some something that I read somewhere that when you start playing piano, you play with the chords. You're very careful. You're playing number 5, number 4, but there's a time you're going to reach until now you're just playing with the heart. Even you don't know what you're doing. It's just within your fingers. So this is the same thing we're trying to achieve here. So many programmers have adopted a martial art metaphor for their practice session. The name coding dojo seems to have stuck. So this coding dojo is more of the martial arts of now the programmers, how they practice. And the first thing in this practice we're going to cover is kata. So kata in martial arts, a kata is a precise set of choreographed movement that simulates one side of a combat. The goal, which is asymptotically approach, is perfection. The artist tries to teach his body to make each movement perfectly and to assemble those movements into fluid enactment. So beautifully well executed kata are beautiful to watch. I know you guys have watched these guys, even, is it Karate Kid? Like how they were doing very uniformed, or rather like the practicing. It's when it's well executed, it's very beautiful to watch. So beautiful though they are, the purpose of learning a kata is not to perform it on the stage. The purpose is to train your mind and body how to react in a particular combat situation. So when somebody throws a fist, you have already a way of how to rather do, rather to defend yourself. So that is the whole essence of kata. So a programming kata, on the other hand, is you are not actually solving the problem because you already know the solution. Rather, you're practicing the movement and the decision involved in solving the problem. It's like when you're doing a two-sum. Actually, I was watching some clip by a blackboard another day. Two-sum. So it's the same, you know the solution, but you have to. Now, kata is when you redo it. You redo it every time, and before I get now maybe a target, a number, I have to do what? I have to get the number within the array, and then I subtract or whatever is within. And then after that, you redo it many times. You do it in a different language or what you're going to. That is the kata now. You're not solving a problem, you know it, but you're just practicing until you know the problem. Yeah. So there's something else called wasa. Now we are moving from kata to wasa. So wasa is very much like a two-man kata. So kata is one person. So wasa is two men playing. So one partner plays the role of aggressor and the other partner is the defender. The motion is repeated over and over again as the practitioners swap roles. So what are the roles here? One programmer writes a unit test and the other one makes sure that it passes. They reverse the roles. So you write the test. We talked about how you write the test. You write the test, then you write the code. You write the code. Okay. You write the test again, you write the code. So these two people in the WASA, one person is writing the test, the other person is going to make sure that test passes. So to make the game to be competitive, now the person who is writing test is the one who is the determiner of how the other person is going to write the code. So you have to make sure. So that competition brings in what you're calling wasa. You're practicing together. So you're having randori. I guess this is more similar to what Nandaa was talking, the mob.
Mob programming.
Yeah, so sometimes we would set 2 or more attackers against a single defender. Yeah, so you're there, you're the defense, you're the goalkeeper. So we'll do 2 on 2 or so forth. So this can be more also. So this randori. With the screen projected on the wall, one person will write a test, then sits down. The next person makes sure that the test then passes, then writes the next test. So you write the test, then another person comes in and make sure that the test passes, another person comes in. So that is the randori. And then I guess many folks we are yet to get there, and that's why we are part of this. We are learning this, and part of PTC. I hope you'll be doing those stuff.
Yeah, you want to bring that idea. It's like our community. Yeah, that's a good one actually to do at PTC actually.
Yeah. So we'll be moving from theory to practical very soon. So broadening your experience. So professional programmers often suffer from lack of diversity in the kinds of problems they solve. Employers often enforce a single language platform and domain in which their programmers must work. So you find the environments we work in, some concentrate on a single program, or rather programming language. Either you're working on Spring Boot, C Sharp, you're working on. So you find that you have concentrated on only one. So as a programmer, how can you get more experience? So that's why we're coming to the open source. I saw Nandaa is doing good stuff. He's posting links that you can. I saw a post where you did on people can contribute on an open source project. Yeah, that's why you can learn, because you are taking on pro bono. Pro bono is similar to what lawyers do, like doing a work which you are not paid, but you are learning as you do it. So if at all you're a Java programmer, like me at the moment, you can contribute to Rails projects. So you can take it something that's a language that you're not using. So right now I'm open, or rather contributing to a code base which is using C Sharp. So I'm learning C Sharp, but it's not part of my work. So whatever you're talking about here, practice, it's something that you do away from work. It's not within the 8 hours. So let's just get that straight. So practice ethics. Actually, that is what next. I think my brain is just working with whatever is here. So because practice ethics is where we talked about programmers should not practice during the employer's time. Yeah. You're practicing away from work. Since your practice time is not your time, you don't have to use the same languages or platform that you use with your employer. Your employer won't come and tell you, hey, you're trying to code in Ruby and Rails. That is wrong. So you're free to do anything. You're free to break stuff. You're free to work with any new language out there, either Golang. Yeah, just practice on something that you're not really working on during your working hour. So the conclusion is
on time, right? So actually, also some employers do encourage like the employees to participate in open source, for example, or learn stuff in the allocated time. Like let's say some would say like a Friday, and this is what I would like to encourage even if startup. This is a good one to start like as a culture of learning and growing, because at the end of the day you're getting back better programmers. So you can decide that all Friday afternoons are the times where you focus on learning a new stuff, whether it's a new language or you're contributing to open source, but it only needs to have accountability. Like it's not like the time now to go and on other things, but rather maybe you come back on Monday morning to report on what you learned on Friday.
Yeah, and there's some. I think there are some companies who are doing that at the moment. I know of some friends I was talking to, and they say Friday is learning time. Like, just like, oh man, should I join there? But no, I'm working at Cloud IT. So let's continue. So, all professional practice, they do this because they care about doing the best job they possibly can. What more, they practice on their own time because they realize that it is their responsibility, not their employers, to keep their skills sharp. Practicing is what you do when you aren't getting paid. You do it so that you'll be paid and paid well. Actually, this is the beauty of it. The more you practice, you're going to be paid better because your skills are going to increase and you're going to become a professional. Awesome. So you're getting to acceptance testing. What is acceptance testing? So from the word acceptance is something you just accepting, yeah. Something has been built and you're acknowledging this whatever that was to be built. So the role of professional developer is a communication role as well as a development role. So there are some folks who really think that software development is only about coding. No, it's more of a communication, because you have to code, you have to communicate with the people you're building the code for. You're not, yeah. So remember that garbage in, garbage out applies to programmers too. So professional
Mhm.
programmers are careful to make sure that their communication with other members of the team and the business are accurate and healthy. How can you make this to be healthy? So communication requirement. One of the most common communication issues between programmers and business is the requirement. The business people state what they believe they need, and then the programmers build what they believe the business described. So the communication of requirements is extremely difficult, and the process is prone to error because I'm not in your mind. Like the programmers are not in the mind of the business people, and the opposite. So whatever they're thinking they want is not. So that communication to really come to whatever like the customer needs. That's the beauty. Or that's where now the real profession comes in to know how to do that. So this is an example. The writer is talking about a person called Sam, or rather Tom, who wanted him to make a very simple ticketing system. And because Tom thought that this program was very simple, he just told the writer Uncle Bob that just show me, then I will code it out. And then when they sat along, and then he started kind of describing what he needs. And then now Uncle Bob started, or rather implementing that. Tom was drawn away. He knew that I cannot do this because whatever Uncle Bob was saying, it's something that Tom was not understanding. It's like Chinese, you know. I just need a login page. Like I just need some word there. I can do it. Then they being told that you have to. There's something to do with JWT. What? Hey, is that part of just logging in? Or yeah, so that's what happened to Tom. So within the first 20 minutes, it was clear that his emphasis had changed from learning how to do it himself to making sure that what I did was what he wanted. So some of the things he wanted were hard to do in ED402, or rather this was the tool that Uncle Bobo was using. So I would propose something else. We'd eventually agree on something that would work on, then I would make it work. So in the end, he got the application he was looking for, but had no idea how to go about building the next one for himself. I, on the other hand, learned a powerful lesson that how customers actually discover what they need. Customers discover what they did when you're building it. Like they have an idea, but when you now create it, I just want it to be like this way. Like, can you make it to be? That's how they learn because there's something that they want it in their mind, but they really don't know like what they want until they see now you have started building. That's when they are going to kind of react. So there's something called premature precision. Let's not forget we are just still on acceptance test. Acceptance we talked about is the end user accepting whatever, right? Whatever has been built. Yeah. So the trap of premature precision, business people want to know exactly what they are going to get before they authorize a project. Developer wants to know exactly what they are supposed to deliver before they estimate the project. Both sides want a precision that simply cannot be achieved and are often willing to waste a fortune trying to attain it. So at the end, we have seen this thing can be vague at some point because people know what they really want, but they don't know. Yeah. So you have to so there's what coming to a precision, or rather the specs to be very clear, it takes some time. So that uncertainty can bring developers saying we are not going to start building until we know what we are in for. So the uncertainty principle, the problem is that things appear different on paper than they do in a working system. When the business actually sees what they specified running a system, they realize that it wasn't what they wanted at all. Once they see the requirement actually running, they have a better idea of what they really want. This is what we talked about. So actually I was in a meeting just a few weeks ago, and like the customer needed something, but they really don't know what they want. So what I propose is that I make a prototype, and from the prototype, which I have right now. In the next meeting, they are going now to act on the prototype. They say, all right, we did something like this, so I'm going to get a better view of what the customer wants. That is what we are talking about. So estimation anxiety. Developers too can get caught in the precision trap. They know what they must estimate the system and often think that this requires precision. It doesn't. So at that point, there's a chapter whole about estimation. We are going to cover it a bit later. So professional developers understand the estimate can and should be made based on low precision requirement and recognize that those estimates are estimates. They are estimates. They are not the. We are going to cover that later. So sometimes the stakeholders simply assume that their readers know what they mean. So this is the assumption principle that you assume. There's a case here, example given of Sam and Paola. Sam needs a log file to be backed up in a system. That's why you see log files need to be backed up. And then Sam says every day, they should be backed up every day. And then Sam says, no, not during trading hours, midnight would be better. And then Paola said, okay, midnight. And so there's some log files that Sam wants to be backed up. So later on, Paola said, goes now to Peter, who I think is the developer who should implement this. He says, we need to copy the log file into a subdirectory named backup every night at midnight. That's the communication. So whatever Peter is going to make is to back up the log file every midnight in a subject in a directory called backup. So, but later, this is the communication that now Carl and Sam is having. Yes, the log file will be saved. And then the customer said, we need to go back through all those log files, even months or years later, whenever there is an outage, even or dispute. Now, this is a challenge. When they were taking the requirements, this was never captured, that it is going to be backed up forever. Like their log files are going to be read every time. But the communication is, Peter is going to print the log file, but it's only a day. It's going to be saved today. Tomorrow there is not the log file, another log file, so there is not that. So that is an ambiguity of how the commission. It is the responsibility of professional developers and stakeholders to make sure that all ambiguity is removed from the requirements. So acceptance test, this is the definition. Acceptance test are tests written by a collaboration of stakeholders and the programmers in order to define what a requirement, when a requirement is done. So that is the essence of writing acceptance tests. So when the software is written, then the stakeholders and developers are going to say, this requirement is done according to these acceptance tests that we wrote. The definition of done. So done means done. You know, you can say done, but it's working on your local machine. And then the boss is going to ask, is the customer going to use your local machine? So that means all code written, all test passes. We talked about tests. QA and the stakeholder have accepted. So all the acceptance tests have passed. So that is now going to be done. So this is just a clarification of the example. The better thing would be, you see, Tom would ask, you mean that there is an active, or rather, but there is only one log file? Let me see. Oh, I thought that I just wanted a temporary backup. No, the customer wants to keep them forever. So there's a communication of ambiguity, like follow-up questions when you're making software. You have to ask so that you can clear the ambiguity. Not just build this, okay, cheers, meet next time. And then you come with the software where the requirements are ambiguous, or rather, customer says, this is not what I wanted. So you have to clear that ambiguity.
Yeah, and even just even a simple one like midnight. Which midnight is it? Which time zone?
Yeah, which midnight? Oh, yeah. You can say midnight, or yes, maybe I work with EAT, but rather it should be something in US time or something. Next. So communication, the purpose of acceptance test is communication, clarity, and precision. By agreeing to them, the developers, stakeholders, and testers all understand what the plan for the system behavior is. Achieving this kind of clarity is the responsibility of all parties. So professional developers make it their responsibility to work with stakeholders and testers to ensure that all parties know what is about to be built. And the acceptance test should always be automated. There is a place of manual testing elsewhere in the software cycle. We're going to see on the testing strategies, but this kind of test should never be manual. The reason is simple: cost. For doing manual tests, you need more people to test your code. So it will mean a lot of money. You have to employ people to test, or rather, yeah. So by automating the tests, you're going to ensure that that the cost is, we talked about that. So there's the aspect of extra work. People are going to say writing tests is going to be an extra work. But specifying at this level of detail is the only way that the stakeholders can ensure that the system they are paying for really does what they need. And specifying at this level of detail is the only way to successfully automate the test. So don't look at these tests as extra work. Look at them as massive time and money savers. So is the perspective of this test, acceptance test. Don't look them as extra work. So the question is, who write the acceptance test and when? So acceptance tests in real world should be done by the stakeholders. But in real life, the responsibility can be given to business analysts, QA, or even developers. But these people should work together to write those tests. Typically, business analysts write the happy path. They don't write about when the users enters what is the date of birth 000 everything that's they don't write about that is a bit of unit test. You're going to cover that, but the happy path is the user is logging in what people should be able to make orders on items, or rather I should see the display. That is the happy path. And QA typically writes the unhappy path. That's why I see there's a fight between QA and the developers, because you have written your code like a baby and somebody is going to toss it up and down. That is the unhappy part. So what is the developer role? The developer role is to implement a feature, or rather we implement the feature begins when the acceptance tests for that particular feature are ready. So you don't start implementing features when you don't have the acceptance test. And this is what many people, or rather not professional developers, do. You start coding without even knowing what the requirements. And then when you're coding, you just, hey, and what am I building? So when you get the acceptance test, that is when you start implementing. So test negotiation and passive aggression. Test others are human and make mistakes. So as professional developers, it's your job to negotiate with the test author for a better test. When you should never do, what you should never do is to take a passive aggression option and say yourself, well, that's what the test says. So that's what I'm going to do. So this is what the passive aggression is where like people have requested, you have not even negotiated. As a developer, when you build this stuff, it's going to fail, or rather it's not going to achieve, but you're there. Okay, the customer said that, so I'm just going to do whatever he said. And then after you build, back in your mind, this is not going to work well. So it's your work as a professional developer to point out, or rather to negotiate. Don't take the passive aggression mode. So acceptance tests and unit tests. Acceptance tests are not unit tests. Unit tests are written by programmers for programmers. Yeah, unit test is where we talked about. You write a unit, you write a test, then you write code. You write test, you write code. That is the unit test. But acceptance tests, they are now we talked about. They are written by business for business. There are formal requirements document that specify how the session should behave from business point of view. So that's the difference. Then we have another form of test is GUI, another complication. There are complications when it comes to testing GUI, or rather graphical user interface. It is hard to specify GUI up front, or rather to test GUI. So how are we supposed to test these layouts? So the layout format, the workflow of GUI will change for aesthetic and efficient reason. We all know this. that every time in the front end something have to change. Either the button or rather the flow, how things are. But now how do you test this? And the beauty of it, despite the changes, therefore, the written acceptance test for GUI, you take advantage of underlying abstraction that don't change very frequently. There are things below the GUI that don't change frequently, either the components or rather things that you have defined. That is the ones that you take advantage of, not the buttons or rather whatever you see. You test with whatever the abstraction underneath. So testing through the right interface. This is what I talked about. You test testing through, keep the GUI test to a minimum. They are fragile because the GUI is volatile. We talked about these things keep on changing. The color, the word, the button. I don't want this to be here. So those things are going to change. The more GUI tests you have, the less likely you are to keep them. They are going to change. So you have written many tests, but they are going to change. So there's some beauty here. We are talking about CI, continuous integration. The system should be triggered by your source code control system. Every time someone commits a module, the CI system should kick off a build and then run all the tests in the system. The result of that test run should be emailed to everyone on the team. Actually, apart from emailing, you can use a tool like Slack. I used it back in when I was doing this practicing. Like when you push something, you git commit, it goes to the code, and then it builds on, it makes an image to the Docker, and then goes to AWS, and then gives me a Slack message of all the flows is going. It is testing, it is now on deployment, and then you get a celebratory message there on the Slack. Your app is deployed. That is the beauty of CI now, because the code is going step by step. So stop the presses. So what is the stop the presses? When the tests are not working, every developer should stop anything they are doing, because that's when the mess is coming in. So here is talking. I have consulted for teams that fail to take broken tests seriously. They were too busy to fix the broken tests, so they set them aside, promising to fix them later. What happened? They forgot about to put the test back into the build. They learned this because angry customers were calling them with the bug reports. So when you failed to write the test, or rather your tests are failing, then you are in for it. Customers are there for you. They are going to call you. So what is the conclusion of this? The conclusion is communication about details is hard. This is especially because true for programmers and stakeholders, communication about the details of an application is too easy. It is too easy for each party to wave their hands and assume that the other party understands. And that's what people do. All too often, both parties agree that they understand and live with completely different ideas. We have agreed, you're going to build that. Okay, yeah, nice, tomorrow. But you've not, you're going to save the log files. Okay, at midnight. Maybe it's China time. So, so the only way I know of to effectively eliminate communication error between programmers and stakeholders is to write automated acceptance tests. These tests are so formal that they execute. They are completely unambiguous and they cannot get out of the sync with the application. They are the perfect requirement documents. So those were the acceptance tests. And now we move on to testing strategies. Any comments from Nandaa? You have any comments or you continue?
No. Nothing. Maybe just to say I've seen that in practice where you say, let's put this test aside, we'll come back to them, and you never come back to them. So that's a common thing.
It's a common thing. But as professional developers.
Yeah. And also, on time, we have 10 minutes, so we can do the testing strategies and then close.
Okay. All right. Thanks for the heads up. So testing strategies. So professional developer test their code, but testing is not simply a matter of writing a few tests, unit tests, or a few acceptance tests. Writing these tests is a good thing, but it is far from efficient. What every professional development team needs is a good testing strategy. So when you're writing tests, it's not just a matter of writing tests. You have to have a strategy when you're doing this. So we talked about this. QA should find nothing. You should not use the QA to to test your code. So that should not be the goal. They ask themselves what happened, and this is what we talked about later on. Some few parts. Any code or any bug that finds you should find you with a horror, like, it happened, manze. I didn't know. So it's not something that you're expecting. You're just like, all right. So QA should find nothing, and these are the pyramid of testing. They are the unit tests in the base. There's the unit test, then component test, integration test, system test, and exploratory test. So unit test we talked about is the basic programmer to programmer. Component test is where you test now the underlying components within the system, or rather you're connecting different components. But unit tests, they cover 100%. Component tests, they are not going to cover 100%. They are going to cover maybe 50% or so. Integration, the upper you go, the lesser the coverage. 20%, 10%, that way. Unit test is developers to developers. Component tests are generally written against individual components of the system. We talked about this. Integration is more of how the system, the plumbing tests, or rather they make how the components, to make sure the components are properly connected and can clearly communicate with each other. So this we talked about is lesser. The coverage will be less as you go. System tests, they are automated tests that execute against the entire integrated system. They are the unlimited integration tests. They do not test the business rule directly. Rather, they test that the system have been wired together correctly. So it's basically written by technical leads and system architects. And I know technical leads out there are not writing these system tests. What's their work, man? So manual exploratory test. This is the last thing we're going to cover. This is where you put the humans together. You put all the people who are using that application, and then they they test something that you are not aware of. They give that 00 and the date of birth, and what they test everything that you had not covered, and they are going to find something. So the conclusion is TDD is powerful discipline, and acceptance tests are valuable ways to express and enforce requirements, but they are only part of a total testing strategy to make good on the goal. The QA should find nothing that we talked about. Development teams need to work hand in hand with QA to create a hierarchy of units. Unit tests, then component tests, then integration system, and exploratory tests. So that is the linear side of the testing. So we reached there today. I thought we could cover time management, but our time has elapsed.
And so, no pun intended.
No pun intended.
But maybe the best way of practicing that time management actually is to I can stop right here. So that's good. Yeah. So, but thanks so much, John. So I know we'll be able to close tomorrow. So for the folks who are out there, maybe who join us late, we have the last installment tomorrow, and we're looking forward to seeing you there. And as I said, I have opened up this invitation to everyone. Like, if you like to come and review any of the books, especially software engineering classics. Okay, my last, what is a software engineering classic? Yeah, just propose the book and we'll let you know. But I don't want to say like it has to be a classic. Any book that you think it's valuable to our community, our software engineering community that listens to this channel, you're so much welcome. Let me know. I said I work with any time, whether you're in Asia or you're in PST, West Coast, East Coast, you're in Europe, you're in West Africa, South Africa, anytime we will work. We'll make it work. and we'll have you on the channel. So you're much welcome, and see you tomorrow for the final installment. And I know you're excited. So have a good day, and again, thanks, John. Thanks for this. This has been a good review. Many people have left comments just saying like good stuff.
Awesome.
So quite enjoying this. So looking forward to tomorrow.
All right. Cheers. Tomorrow. Adios.
See you.
All right.
Good.